Hello and welcome to episode 9 in the Delphi Training Series, brought to you by 3dbuzz.com. My name's Buzz.
And I'm Logan.
And as a reminder, 3dbuzz offers a dedicated online classroom to go along with these videos. It's the perfect place to ask questions if you find yourself having any trouble whatsoever. A bunch of great people over there willing to help you out. Also, if you happen to be viewing the low-resolution version of this video, keep in mind that we do make the high-res version available because I know it can be very challenging to see the text in the low-res version. You can get the high-res 12 to 24 hours after the low-res is put live, and you can also get it from the classroom. The link to the classroom is 3dbuzz.com/Delphi. All right, with all that out of the way, let's get started. In this episode, we're going to continue with our short break away from the MP3 player that we've been developing so that we can cover control loops. We need to do it, guys. Control loops are going to quickly become very important to us, so we need to go ahead and take a dedicated lesson and cover them. As always, though, by the end of this video, we're going to take the time to write a simple but interesting application. So what are we going to cover in this video? Well, first of all, what exactly is a loop and why do we need loops? We're going to look at 3 different types of loops available to us in Delphi. We're going to look at the repeat loop, the while loop, and the for loop. From there, we're going to create a very simple application that is going to run through a folder structure on your hard drive and grab all the names of the files and folders and list them in an application that you write. So we're going to have to do a little looping there. And then we're going to progress into another application that's a bit more interesting. We're going to create a sine wave generator. And this is going to introduce you guys to some very simple drawing code. As a matter of fact, Logan, if you don't mind, go ahead and bring that up real quick.
All right, here's a prototype version of the Sine Wave app.
Okay.
And as we mess around with these sliders, the application draws a sine wave for us.
So you can see as it changes the amplitude and the frequency, the wave updates on its own. So really good stuff there. Now, let's go ahead and talk about what a loop is. They're pretty important, wouldn't you say?
They're very important. Anytime you need to have the application do complicated number crunching, or you need it to continue doing something without your input, like a game that plays even when you're not adding input.
Basically, anytime you need for something to occur over and over and over. I mean, as we all know, let me go ahead and bring up my whiteboard and do some scary writing real quick. As we all know, an application is written and it executes very linearly, as we saw over and over and over through these videos. But what happens when we get into a particular situation where, let's say in a game environment, we need for our code to, let's say we have all these little enemies out here, right? And during each iteration of the game loop, there I go, using the word loop, each time the game goes through one iteration of time, if you will, we need to address all of the enemies and make sure they're all wandering around or attacking or defending or something. We need to just basically take a look at what each enemy is doing. Well, in writing our code, we can't really ahead of time write a line of code handling each enemy. So we could say this line of code is handling enemy 1, this line of code is handling enemy 2. I mean, what happens if enemy 2 just happened to bite it? So he's no longer around. And now we've got a bit of a problem. But if we had a section in code that looped, so in other words, let's say that this handled a particular enemy, and when you got to the end, it came back up, and then we handled the next enemy, then it came back up, and we handled the next enemy, and we kept looping through all of the enemies until we've addressed each one, and then once we're finally done, we continue moving along with our program. Makes things a whole lot easier. Actually, better way to put it, it makes things possible, because if you don't know the total number of entities you're going to be dealing with ahead of time, there's no way you could hard code it all in linearly, line after line, right?
Right. A loop is a key component in dynamically controlling things in your scene. You have one block of enemy instructions, and you apply them to a future or unknown number of actual enemies when the program runs.
Exactly. Another place that you might find a loop, let me think. How about if you were searching through your hard drive for a particular file? Your program, when the developer wrote the application that's going to enable you to search all your files, he doesn't know how many files are on your computer, so you need to find out how many files are on it within your application, and then walk through each one, checking it against, well, whatever the search criteria entered was. So there you'd go. You'd simply say, we'll code over here. Hey, like my dot coding, Logan. So we're going to enter in our little piece of information, and then we're going to grab a file, make a comparison, and then check to see if it's the last file. No, it's not. We're going to come up here, grab the next file, make our comparison. Is it the last? And we'll just continue doing that until we've walked through every single file. And, of course, once we've hit, it matches our comparison, then perhaps, we'll exit out of the loop and then do whatever we need to with it. Just a real quick example.
Right. There's a lot of times where data will be given to you in a record-based format when you have a lot of data. In cases where you have files on a computer, or even if you get into database stuff, where you get each record is something you handle one at a time, and you have to loop through a lot of those records.
Precisely. Now, obviously, in our MP3 player, we're going to get to a point where we're going to have to start doing some looping. One place, Logan, thinking about it, that we haven't really shown them how to do is, in the MP3 player, let's do some more drawing. Here's our little MP3 player, right? And we've got that place where we can add files in, right? And we hit the little button down here, and it opens up the Windows dialog, and you go in here and select a file and click OK, and it puts that file in the list. Well, what if you want to go in here and select a file, hold Shift, and select another file so you've blocked an entire range? Now we need to loop through all of those different files to populate them into this guy here, right?
Right, because whatever happens when we open a file, there may be multiple instructions that we have to do per file.
Exactly.
So we have to take those and apply them one by one to each file that's coming in from the file dialog.
So we're getting ourselves into a situation where we're going to quickly need to employ loops. And that is why we need to take this lesson and cover them. So, with that out of the way, let's go ahead and clear my whiteboard and begin with the first loop that we're going to cover. It is a very, very simple one. It is the repeat loop. And the syntax of it looks like such. You start out with repeat, and then we indent because we want to keep our formatting looking nice, don't we? So we'll have our statement 1, terminator, statement 2, terminator, statement, however many statements you want that is going to basically take place each iteration of the loop. And then we have until, so we're going to repeat until, and then we're going to have an expression. Ooh, an expression and a terminator right here as well. What is an expression? Well, we just covered this in the last episode when we went over if statements. Remember, the expression was when we said if, and then the expression was x equals 5 or x is greater than 5, our test. That's our expression. So the same thing is going to take place here. So if we were to write a very simple thing. Let me try to think. What would be a really simple one? I know. We'll use A just like we did the other day. We can do something like if we had a program there that said A equals 1, then we're going to say repeat. And we're going to write out. And we're going to say A equals, and we'll print out whatever A is, and a terminator. And then I'm going to take A, and I'm going to come in here and increment it. Or you can just increment it, do it that way. And we're going to do this until A is greater than or equal to 3, terminator. All right, so we're going to write this little program in just a minute inside of Delphi. So get that in your head, Logan. Memorize that. What does this look like if we were to block it out? Well, we'll start out our little program down here by saying A equals 1. Okay, check. Now what we're going to do is we're going to drop down and we're going to print something out. And I'm just going to use a little question mark for print. So we're going to say print A equals and then whatever A is at the moment. Okay. The next thing we're going to do, so that's this line, check. Next thing we're going to do is we're going to take A and increment it. So A equals A plus 1. So check. Then we're going to do a test. So just like we did with the if statement, we'll do a little diamond down here, and we'll say, is A greater than or equal to 3? I promise you guys that is indeed a 3. And if the answer is no, it's not, what we're going to do is we're going to come right back up here and join the party again. And so what we have just created here is a loop. And this is our repeat loop. So again, this right here is a no. And if it's yes, we're done with the loop and we'll just simply continue on with our application. So let's actually follow this off. And by the way, if you're going to throw some check marks in here, that loop just took care of those 2 lines, and that is our entire program. So when the program runs for the very first time, remember here is our little variable slot, A, and we put a 1 in it. And when we come through out on our console, we're going to print out a 1. So that's this line. Now we come down here to this line. We're going to increment 1 to a 2. Now, is 2 less than or equal to 3? Yes, it is. Is it greater than or equal to 3? No, it's less. So we come back up here and we now print out a 2. And then we come back down here again and we increment the 2 to a 3. Now we come down and is A greater than or equal to 3? Well, it is a 3. Yes, we're going to move on out. Make sense?
So we just continue until a condition is met. It's almost like a special kind of if. It's the same type of decision. At the line that has the until, we run the expression. In the case of a false or a no, we jump back up to a place in code marked by the beginning of the repeat loop. And then if it's yes, we just continue on and we don't bother looping.
Exactly. So let's go ahead and write this one inside of Delphi real quick.
So to do that, we'll start a simple console app because that would be a very easy way of getting directly to code. So from other, we have console application, and now we're ready to go.
We'll just go ahead and create a variable A as an integer.
So A is our variable. So, all right, we've got an A variable.
And then let's just write the same exact thing that we had over there. We'll just start out by initializing A. You never want to just jump right in and use a variable without initializing it. That's something that somebody pointed out over in 3D Buzz, which was a really good, moment to point that out. So thank you very much. It's something, believe it or not, Logan, we kind of skipped over when we introduced everybody to variables. Obviously, when using a variable, when you declare one, you're going to use it, but always make sure you initialize it. Make sure something's in there first, because you never know. You don't want to get just some random junk in memory and start doing work with that.
Right. If you did a comparison after you've defined it, it could still contain something because it's basically that variable lays over your computer's memory, and there might have been something in that memory.
And we could even demonstrate it right here. If you don't initialize A, go ahead and put 2 slash marks in front of that. All right. Now let's jump down to the next one. So we'll start the repeat.
So repeat.
And then next line, we'll go ahead and jump in. Oh, isn't that nice? It puts it all in there for us. Let's go ahead and do a right line. And
just because I'm picky about capitalizing.
Yeah, that's cool. And then we'll open and do a single quote, A equals space, and then, comma A.
So.
And then in parentheses, terminator. And then, of course, now at this point, we need to make sure that we increment A, because you can get yourself in a situation where you have a loop that's going to, run forever.
Or an infinite loop.
Infinite loop, run forever, infinite. You guys get the idea. And, of course, we want to avoid that. So in the next one, go ahead and do something like A, and colon equals A plus 1. And then let's go ahead and on the until line now, we can say until A is, let's do something bigger than 3. Let's say 10. Greater than or equal to 10. And let's go ahead and run this.
And
let's go ahead and
add in a read line.
Yeah. Notice, though, at the bottom, it's great that he compiled it. At the bottom, you do have a variable A might not have been initialized. So it is warning you that you might have a problem. Let's go ahead and run that. And, look at that really unpredictable, scary, freaky number.
Yeah, we never said anything about 2, blah, 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 blah.
So watch this. I can show you this. Go ahead and close that. This is fantastic. Change the greater than or equal. Just take the greater than out. So now, technically, if your code starts off with A being initialized to 1, we know that we can get all the way up to 10, and it'll print 10 out. And the next time through, it's going to stop as soon as it hits that 10, right? But run this. Since we're not initializing A, watch what happens.
And I'm going to run this one with debugging so I have better control if anything happens to it.
Like that? And this is one of those situations, unfortunately, we're just never going to hit 10. Because we started out with some random goobly goo in there, and we're incrementing it.
Well, we just flipped around, so if we wait a really long time, we might eventually get back to 10. But this, I would definitely say this qualifies as undesirable behavior for our application.
Indeed. So let's go ahead and close that out.
So I'm going to break the app and have it all stop.
All right, so now let's initialize A, and let's take a look at the difference. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good.
Because we began at a known place.
Yeah, here I am saying that it's going to print out 10. I'm thinking a little bit too fast right now. What I was wanting to say. The key thing about the repeat loop when compared to the other 2 types of loops is it will always, let me grab a mouse right here. It will always execute the statements within the loop at least once, always. So we could really demonstrate that by saying repeat until A equals, I don't know, what do you put a 1 in there? So now if you were to run it, And
well, we have to wait till it wraps back around because we're incrementing it.
Yes. We just went about. So hang on, let me see. Do I put a greater than in there? Yeah. So if it's greater than 1, it starts out 1. That's going to start right away. So go ahead and run, and it does indeed run through the stuff one time and it jumps out. That's what I wanted to show you guys.
Right. What it comes down to is because these statements appear before we actually do the check to decide if we're going to continue looping, that means they always get written. Even if we're in a scenario where this will never be set up to where it loops.
Right.
We'll still run this before we figure out that we're not supposed to loop.
Well, to prove that real quick, here's my example. Where it was greater, put greater than or equal to 1. So we start out right there, and A is going to be equal to 1.
Right,
so we'll fall out.
Right. If we had done that check first, we would fall out. But because we're doing it afterwards, we print it out.
So there you go. Now, if it was another kind of loop, that could present a problem for us. So repeat is real simple. And we're going to do a little application in a few minutes. It's going to use the repeat to walk through and grab those files and populate a list for you guys. So very simple stuff. I mean, obviously, there's probably 1,000,000,001 different examples we could use, but at this point, as long as you guys have the very basic structure of how it works, I think we'll just stick with this, and as we start using it in the applications we develop, you guys will get a better and better feel. Feel free to go in there and play with it. The bottom line is you're going to repeat until an expression is true, and that's what we're doing here. The moment it's true, we're going to jump out of it. And like I said a second ago, you will always do the guts, if you will, of the loop at least once, no matter if the expression's true or false coming in. It'll always do it at least once. And I promise you, there's going to be times you're going to write applications where you're going to need that behavior. You may go into a loop with a condition that's going to exit you right out of the loop, but you need the stuff within the loop to happen one time. So repeat would be very advantageous. So that's the repeat loop. So the next one we're going to take a look at, and I guess I can go ahead and bring up my whiteboard real quick. Grab my pen here. And here we go. Get rid of all of this. The next one is going to be the while loop. So the while loop. And again, to go ahead and give you guys some basic syntax on how that's going to work, I'll write this one out 2 different ways, and then you guys can, for the for loop, I won't. So you can say while, and then we're going to have the expression again. It's our little test. Do statement, terminator, or while expression do, and now we can do begin, and I'll just put S. Statement 1, statement 2, so on and so forth until we reach our end terminator. So what's the difference here between the two? This one is going to allow for compound statements. This one is going to only allow you to do one statement, just like we saw with the if statement, right?
Right, and then that makes the repeat kind of a special case loop where you don't have to do the begin and end to do multiple statements.
Exactly. So with this, another quick example, and you guys just bear with me. That's why you have your little track bar, so you can always fast forward. Do another little program where we say, let me just kind of block this out over here. Such. We start out with A : equals 0, terminator, and then here we go in action. While A is less than 3, do, and now I'm going to do a couple of things. So I'm going to do a begin, and then I'm going to tell it to do another right line, and we're going to say A is equal to, comma A, so we'll print that out, we'll know what it is. And then we're going to simply do the same thing we did with the repeat, which is A : equals A plus 1, terminate, and we will end this like such. And if we were to block this out, it would look like this. We'll start out by saying A is equal to 0, and then we're going to come down. Now check it out. Here's our difference. We're going to start out with one of those diamonds. We're going to start out with a test right away. Is A less than 0? If the answer is, we're going to come down here, if the answer is yes, then we're going to go ahead and print out So we'll print out A equals and whatever A currently is. Then we're going to come down here and we're going to take A and increment it by 1. And then we're going to come over here, come right back up, jump right back into the party, and once again, we have just created the loop. When we finally get to the situation where A is no longer less than 3, then we hit the no spot, and we'll just continue. The difference between the repeat and the while. Notice we're hitting this guy right away. We hit the test at the very beginning, which means that the guts of the loop may not execute if you start out with your expression not letting you get in there, right?
Right. If it begins with the expression resolving to false,
that's right,
then it could completely skip the code altogether, because right from the beginning, expression was false, loop was skipped.
Yep. So when this comes through, what's going to happen, we follow execution, is A gets set to 0. Is 0 less than 3? Yes. Well, then let's do this. We're going to write out A equals 0. Then we're going to increment A to a 1. Now we come back up here again. Now check this out. We're rerunning the expression. We're rerunning the expression every single time. And that's the key thing to remember when you start comparing the differences between the while loop and the for loop, because the for loop's not going to run an expression test every single time. So now we've got a 1 in here. Is 1 less than 3? Yes, it is. So again, we begin. We're going to write out A equals 1. And then we're going to, on this line here, we're going to increment A to a 2. So we come back up here. Is 2 less than 3? Yes, it is. So again, we're down here now. We're going to write out A equals 2. And then we're going to increment A. So A now becomes 3. And again, we jump right back up here. Is 3 less than 3? No, they are equal. So at this point, we skip and continue on with execution in our application. The end. And this becomes our output right here. So anything you want to add to that, Logan, before we show them?
No, I think that covers it.
All right, let's show them real quick. Jump over into Delphi for me.
All right, do you want to leave this one lying around?
Sure, you can leave, or it doesn't matter. Do whatever you like.
Then I'm going to comment it.
That works for me.
And push it out of the way so we focus up here. We began with, you had A set to 0.
Yep.
Then we did a test, which was, or we began the loop, which was...
So while A is less than 3...
Or just being picky. So while A is less than 3...
Do. And since we had compound statements we wanted to execute within the loop, we did a begin end. And then we just write out, you can steal that line down there.
Almost got it.
Yep.
So A is equal to, and then give it A. And we'll increment A by doing A is equal to A plus 1.
There we go. Let's go ahead and run that. And 0, 1, 2. Just like we traced out over on the whiteboard. So, you guys see how it works? Pretty simple, pretty straightforward. And when we do the generator, the sine wave generator, we will start out by first using a for loop, and then we will change it up to use a while loop because it's a bit more efficient. But you'll see the for loop next. So we are going to see this in action in an application in a few minutes. So next thing we want to take a look at is going to be the for loop. So let me go ahead and grab my pen and come down here and jump us over into, ooh, that's kind of scary looking. So this one, the final loop that we're going to be looking at the moment is going to be a for loop. And its syntax is pretty straightforward. Actually, it's very straightforward. It's for. We're going to have some sort of counter, so a variable. And that counter is going to be equal to, that is an INIT, yeah, wait a minute, value. So initial value to a final value do, and then I'm just going to put it right here, statement. But you guys remember, if we had compound statements, we're not going to have anything right there. We're going to do a begin and an end and put all of our statements in there. Now, for comes in another flavor. That's why I'm just kind of saving a little space here. Or, and it looks exactly the same. So we've got for counter is equal to our initial value. Then instead of 2, this is what changes here. We've got down 2. Then our final value do statement begin, end if we need, and then terminator. So we can count up and we can count down. So you may be thinking, well, what does initial value and all that good stuff means? Well, real simple, a really quick application. If I were just to come in here and say for A colon equals 0 to 5 do, then I can have a begin. And then inside here I can say right line A equals. Now watch this. A little different here, eh? Where's my A equals A plus 1? I'm not incrementing A this time around. That's how for is set apart from our repeat and our while, especially from the while. Is that this time around what we have going on right here is we have a predetermined number of iterations that we're going to do the guts of the loop, if you will. So the loop is going to go through here and do them all the way up to 5, and including 5. And then once A is basically ready to be incremented to 6, then we're done with it, right? Right.
It gives you the predefined range, and it also takes in the variable you've given it. In this case, we're giving it the variable A. It uses that variable internally to keep track of where it's at, and you, of course, can still access the variable yourself, and that's why you could write out what A currently is inside of the loop.
One thing, so this is a bit different than those of you that are used to programming in C or C++, where you get a lot more control when working with a for loop.
Well, in those cases, the for loop would also have an expression.
Yes.
In this case, the for loop does not have an expression. It has a given variable and a range.
And the other thing that's going to set it aside outside the expression thing is you can't go in there and muck with that guy there.
Right. It actually takes that variable for its own use, so you can't go in and mess with it while it's within the loop.
So I couldn't come down here and say A equals A plus 1, right?
No, because
that'd be all bad stuff. So I won't block this one out because it's going to look basically the exact same way. Let's go ahead and code something that looks like this over there inside of Delphi. I'm sure everybody's getting tired of watching me draw by now.
All right, let's move some of these around a little bit because now we're done with our while example, so we can push that to the side. And we need to begin a for example. As a matter of fact, we can comment this out as well and push all of that out of the way. So beginning, we say for A is equal to 0 to 5 do, and even though we only have one statement, we'll keep it like the other example and start with a begin. We'll write out, and this time I will copy it, write out what our A value currently is. A is equal to
and that really is
A,
it.
And we're done.
It's that simple. So there you go. Notice how we did do it for 0, for 1, 2, 3, 4, and 5. It's not one of those situations where we have an expression where we're going to say for, and we're going to go from where while 1 is, or while the counter is less than 5. Not one of those type things. It's just a predetermined number of iterations you're going to go through.
Yes, we're given an actual range. We specified that it begins at 0 and it ends at 5, which means we will get to process 0 and we will get to process 5.
So some people might be thinking, well, all right, well, how do I know which type of loop to use? Well, when you go into it, think about it. Obviously, you can make most loops work for you in most cases. But when it comes down to it, the for loop, if you know ahead of time exactly how many times you need to loop through something, well, this is great because you don't have an expression that is being evaluated each new time you're about to go into the iteration of the loop, right?
Right.
The while, you do. So every time it does the guts of the loop, comes back up for the while. Now we need to do a check again. We need to execute that expression and get a true or false out of it. And if that expression happens to be complex, you may notice a bit of a slowdown in your application, depending on the complexity of the expression.
And it works the other way, though, with the while loop. Because you're running an expression, that expression could be a function you've written.
Yep.
That function could, in turn, then control the loop, because if the function returns true or false,
that's right,
you could have the function decide on if the loop should end or not.
Yeah, get out of the loop sooner than later, depending on circumstances. So you get a lot of power with the while loop, but you can see where that could also bite you in the butt if you're not being careful.
If you were given a list, like maybe out of an open file dialog, all right, I want to start at file 0 because it's the first one, and the last one it's telling me is 10. So if I loop from 0 to 10, I can handle each of the files that have been given to the loop.
So keep that in mind. So there is a quick look at the 3 types of loops. Now let's have some fun. Let's start out really simple. Let's go ahead and start a VCL application that will allow us to grab folder and file names and dump them into a list.
Okay. So, starting new application, we'll grab a VCL Forms app. And to display this, we're going to use a memo to display the results of whatever folder we were in. We're going to need some way to specify what path to search from, and then a button to initiate the entire search. So let's begin with the memo. I'm just going to draw out a memo to roughly fit the window, maybe something like that. Then we need our edit to specify a given path. So drawn anywhere around there will work. And finally, a button. So here we've got a button, everything laid in place. Maybe move down just a little bit. Like so. Now for the memo, just to visually clean things up a little bit, I'm going to go and take out that memo 1 line from the localizable section. So I'll grab memo 1, take that out. Or did I?
No, you got to hit the delete key.
Oh yes, the delete part of the deleting something. And then on the edit, instead of having it start at edit 1, the path I want it to search is that setup folder we've been using for Delphi so far. So I'll specify C setup.
Okay.
And one last thing. On the memo itself, I want to set it up so that the memo has scroll bars. All right, now we can code in the heart of the application. In this case, we're going to have a special procedure, or our own procedure, called getFileList, and that'll be the heart of the application. So we'll say procedure getFileList, and this procedure will take in a path as a string. So inside of getFileList, here's where we're going to go and take in that path. Now we need to ask Windows what files are available at that path. And one way we can do that is by using the find first and find next functions.
Okay.
And those have been set up for us within sysutils, so we've got a nice convenient Delphi implementation of them waiting. So to begin this, we're going to run find first. We're going to tell it where we want to start looking. Now find first is going to need something called a search record. It needs a record that it can use to remember where it was currently at, and also use that record to give you the information of what file you're currently on.
Right.
And so before we run the find first, we'll need our variable for that record. I'm going to call the variable SR, and it will be of type T search record.
So a little more complex of a type than an integer or a single.
Right. It's basically a whole lot of information all blocked together in one variable.
Precisely.
So now we can begin our find first. So we'll run find first, and it takes in a path. Well, we're specifying a path in the path variable. Now the adder to this, or the attribute, the find first the finding system can be used to find different kinds of files, folders or any kind of file or hidden files. And there's constants that represent these values, because you can see here it's an integer, so we could just plug in 5, but we have no idea what 5 actually means to this function.
Right.
So what I'm going to do is I'm going to hit F1 to jump into help for this, and we'll load up the find first routine. And if we scroll down a little bit, here's the adder parameter. We have all the different things it can represent, including any file. So I'm going to grab this constant for FA any file, paste that in place, so we use this to find any kind of file it can. And the last thing we take in is a tsearchrec, which we happen to have one of those as the variable SR. So this should get us started with our finding ability, because SR will be used later to hang on to this one search so we can continue from where we left off.
So now we just found our first thing.
Exactly. We found our first thing, stored it within SR, and now we need to find the rest of the things that may potentially exist. So to find the rest of them, since we don't know how many of them there are at this point, we need to do a loop, and so that way we can loop through all of them. So we'll begin a repeat loop, because you'll notice while we've stored the file that we found, we haven't done anything with it. We haven't printed it out in that memo.
Right.
So we'll begin a repeat, and what we want to repeat is the actual output of any files we find.
Mm-hmm.
So we can use the memo, say memo1, access its lines, and have it add a line.
So we need to go ahead and dump this first thing we just found.
Right. We have found one thing. We haven't done anything with it yet. So we'll jump into the loop, and before we do any further checks, we'll go ahead and add that file. So the name of that file is stored within the search record, so we can access it by saying sr.name, and then there's our file name.
Okay.
Now this is the purpose of the loop, to echo out names. Now we need to have it continue. So we'll be using the untils expression to both check to see if we're done, and the expression itself is what's going to continue finding files.
Right.
Because this is where we're going to put our find next. So we'll say find next.
You can see our expression now is a little more complex. It's actually a function, basically.
Right. It's not just our own equality check. We're having some other function run and let that function tell us if it's done or not.
Exactly.
And in the meantime, that function running is going to advance it to the next file in this case. So all we have to feed it here is the search record, because everything about the search is also held within that. So all we need is one search record to be passed to find next. And just as kind of an internal cleanup thing, we'll run a find close after all this is finished, just to tell it that we're done with this search record.
Change that. There you go.
Find, like so.
Okay.
And this is our get file list. Now we just need to invoke it. So we'll jump over to the button, and when the button is clicked, we'll have it run our get file list procedure. And for the path, we'll feed it that edit fields text. So we'll say edit1.text will be our path. So now if we run, let's fix all the errors. We've got, I see, okay. We did, this doesn't return a true or false, it returns
integer, basically.
Integer, and if there is, if it returns 0, then nothing's left. So we know that if find next found nothing, then
basically,
we're done.
if find something, it's like a true in a way, because there's something in there.
Right.
So it's just going to return us a 0 if there's nothing else there.
Exactly.
That looks good. That'll work.
So let's try this out. With C setup and nothing else specified, all we get is that one setup folder. This is because the search record works more or less like a search. We can specify exact things, in which case it pulled up the exact thing we typed in, or we can specify a wildcard and have it pull up everything. So we'll use the asterisk as our wildcard. And now we've loaded everything within that. We also might need to clear the memo out before we start, because we had this from our last search.
That's a good idea. Let's go ahead and do that real quick.
So before we run a get file list search, we can clear the memo. So I'll have memo 1 clear. So now we can run by itself, just setup, or specify a wildcard for everything, and then we have everything inside of setup.
And you can do something like star.mp3.
And now we've got our search rained down to just MP3 files.
Very nice. All right, guys, that is a simple repeat 4 in action. Let's move on to something a little more complex.
Well, that was a quick program, and I'm not even going to save it. I'm going to just go ahead and move on. So we'll do a close all. We'll do a new VCL app. And now we're ready for the sine wave generator. So inside of this app, we need to have an application that I guess you could say its simplest purpose is to draw a line across the client area of the window.
Right.
And we'll use this drawing ability to then affect how high the line is drawn and use that to sample for a waveform.
Right.
The source of our waveform is going to be the sine function to give us a sine wave.
So obviously in this particular case, a procedure called something like generate sine wave would be very convenient, where we could put all of our drawing code in there and we just simply call on that procedure every time we needed to draw the sine wave.
Sounds good.
So let's start out with that procedure, and let's just start real easy. Let's just draw a straight line.
So we'll begin with a generate sine wave procedure.
Now, what did you just hit again? I just saw somebody on the forums there that you did a Shift Control C.
Yep, that's what I've been doing. Every time I go and prototype a procedure and then implement it, I hit Control Shift C to have it fill in the procedure, the begin and the end block.
All right, guys, I'm not bringing your attention to that anymore. Someone posted about that yesterday.
All right, so we're inside of generate sine wave, and our short-term goal right now is just to get a horizontal line drawn across the screen.
In the center.
And have it centered up on the screen. Now, the way we're going to draw this is a pixel at a time, because of course we could draw one single straight line, but then that's not very useful for a curvy sine wave.
Sure.
So the idea is to draw a line pixel by pixel all the way across the screen.
Okay.
So we're going to need a for loop.
Okay.
Or I'm going to use a for loop in this case because I know how wide the window is. Now we'll need our index variable, our counter. So I'm going to specify I as an integer that we can use in the for loop. So you could say for I is equal to, let's see,
Start
0.
out at 0, which will be the left side of X, if you will, of the form.
Actually, one pixel off the left, but that's close enough. It'll draw onto the form.
Yeah, exactly.
And we'll keep looping to our client width for the window itself. So client width, and I'll do -1 just so we hit the 1 pixel before, since we're starting at 0, and then we're going to 1 pixel before the end, so we'll have the actual number of pixels in the whole thing. So with that, we'll put in our do, and we're going to be doing multiple statements, so I'll add a begin and an end. So now, inside of our loop, we need to draw a line. And for the line drawing, I'm going to use the form's own canvas. So we have canvas, and then inside of canvas, we have the line to procedure, which takes in an x and y coordinate. Now, because our source data isn't exactly in two-dimensional coordinate format, we have, well, now we're going to have a straight line, and later we're going to have a wave. I want to hold some variables for our coordinates. So that way, because the bottom line is we have to remap a wave into some kind of coordinate we can draw into a window. And it would be convenient to have these coordinates pre-stored before we send them over to the line too. So I'll create an x and y integer. And for our simple version, we can have x be set to wherever we're at in the loop, so we continue across the screen horizontally. So for now, x is just equal to I inside of the loop. And the y can be set to the center of the screen, which would be our client height divided by 2 and all that. So client height divided by 2.
And you guys saw client height in the last VTM, as a matter of fact.
Right, we used that in the if where we were throwing the ball around. We're using the client height and client width to get the client area of a window that we were playing
Exactly, and in this particular case, client height divided 2 is very important so that we start out with our baseline being center of the screen.
Right, more or less just saying go halfway down the current window.
Right.
So we have our x and y, and we can plug those into our line 2.
So in this particular case, when we start off the loop, first time we go through the generate sine wave, x starts out at 0 because the loop starts out at 0, so our first pixel is going to be at 0. Then when we go back to the loop again, x is going to increment to 1, then to 2, then to 3, then to 4. So each time a pixel is going to get drawn at the center in regards to the y, or the height of the form. But it's going to start out at 0, 1, 2, 3, all the way over to the width of the form minus 1. So we should see a straight line all the way across. Though I do believe we're going to see one very interesting thing at the very beginning of the line.
Right. Now, to invoke this, we'll need some way we can get to it. I'm going to use a button just like in the last example.
That's right.
So this button will have our generate sine wave procedure. We can compile, we can run, and we'll click the button. And we do have a horizontal line, but we also have a vertical line.
Yes, we do.
And just to show exactly how this is working now, I can slow the entire procedure down. Just thought maybe I'll try this to show how it's drawing. You can see it very quickly jumps, and you can see it draw the rest of the way across the screen.
Which makes me wonder, is 0 off the screen, or is that at the very first one?
And 0 is along y, let's see.
So when x is set to 0, is that actually
okay, so that would make sense. 0, 0 is this top left pixel.
That's
so
right. Good.
0 here would be...
I've been sitting here kind of quiet thinking to myself, it's drawn off the screen. That's not how I knew it worked. It was kind of blowing my mind and everything.
I think I was still stuck on our XY floats from the other example.
Okay, I just feel better now. Thought I was really losing my mind. Okay, good. So now we've got this problem we need to fix where this line's being drawn down. By the way, very slick with the sleep function there.
That way you can see that it's being drawn pixel by pixel instead of one instant line.
Very nice.
But since it slows everything down, I'm going to delete it out now that we've seen that work.
So now we need to find some way to actually start our pin, if you will, at that halfway point, because right now the pin is starting at 0, 0. Very easy to do.
And we can see that the line 2 is moving some internal position, because every time we go to redraw after that, we're not still drawing from that top corner. We're continuing from where we left off.
That's right.
The problem is we need some way of beginning without drawing a line.
And if you don't believe us, put sleep 1000 in there. That's right.
All right, so we've got... We need to move the canvas's starting point, and there just happens to be a procedure called move to. So we can use canvas, and inside of here, there we go, move to, and specify any position we want. So we want to move to 0 and x so that we match up with the beginning here, and we want to move to the center of the window so we can grab that client height divided by 2. And now if we run, we have a horizontal line, and because we told it to begin at this point, we don't have any of this vertical line stuff being drawn.
Very, very nice. If we take that -1, go ahead and take the -1 out of the client width. And run that again. Run that. Okay. Yeah.
That probably does hit the last pixel calculation-wise. I'm not sure how client width ends up with the border of the window itself.
Okay.
So it's hard to see.
Looks like it went over one more. But all right, continue.
All right, we've got we've got a very simple line. Now, before we move on, I do want to do a few things just to make this line easier to see, and I'll do that by messing around with the canvas's pen.
Oh, yeah, good
Right
stuff.
now we've got a black 1-pixel line, and it'd be easier to see and more pleasing to the eye if we had a blue line that was maybe 3 pixels wide.
100 pixels wide.
So also under the canvas, we now have a pen held within the canvas, and that pen has properties like color and width. So we'll set the color to CL blue, and we'll set the pen's width to 3, so we have a much thicker line.
3 pixel thick line.
So there, much more visible.
Yep, I see it.
And I'll just restructure some of this a little bit, maybe like so.
All right, so now we're ready to get a little action going, a little sine wave, up and down stuff.
All right, to do that, the way I want the sine wave part to work is to store a current position along the wave, or a current sample, and the actual value of that sample. So we'll need 2 variables. I want to store a sample number and a sample value. So we'll have, there's our sample num. It's going to be an integer because we have whole samples. It'd be kind of weird to have a floating point version of a sample.
To go along with the way he's coding this right now, he is coding these in with a global scope.
Right, because especially in cases like the number, that's going to be critical to the actual sampling procedure itself. That's how it's going to remember where it's at. Value just kind of goes along with it, and that's why I've got that as in global scope as well. The difference here is that value is going to be a floating point, just so we have more accuracy on the actual sample itself.
Right.
So we can store information about a waveform. Now we need something that will populate these variables, and that's going to be a get next sample procedure. Procedure get next sample. And I'll leave it simple for now, no arguments. We might get back to that in a little bit. But I'll take this and we'll lay out the skeleton of this. Now, inside of here, we need to begin with that sample number. We need to have get next sample move on to the next sample. So we'll begin by incrementing sample num. And after we have moved on to the correct sample, we need to store that sample in the sample value variable. So sample value is equal to, now we're going to be sampling the sine wave. So we'll use the sine function. And now in order to have the wave continue, we need to sample some value that increases.
Yeah, it needs to be changing, right.
And we have a sample num that happens to be incrementing every time we resample, so that would be a great value to sample from.
And as you guys know, or may not know, sine wave's going to give you 0 to 1 to 0 to negative 1 to 0 to 1 to 0 to negative 1. That's up and down nice and curved. There you go. Line.
But yeah, that's the source of our wave. That way we're basically turning the result of the sine function into a visible wave. So with get next sample set in place, we are now using our sample num and sample value. So we could go back to our loop and replace our temporary information with some actual wave information.
Okay.
We can replace x with the sample number, so that way horizontally we stay in sync with the wave. So sample num gets plugged into x, and y will be the sample value. Now we can't directly use sample value because it's a float and y is an integer, so we'll have to round this down to an integer.
And we also need to go ahead and take into account the middle of the screen.
Right. As a matter of fact, we could show that by running it real quick.
Oh yeah, good point.
If we run it now, well, we've jumped from, from the bottom up and pretty much off the screen. So yeah, we.
Well, actually, are we? Hang on, we're not doing any calls to.
Okay, yeah, it was
get next sample.
So we're never populating this,
so,
as in we're never actually running across the screen. So that would be a very
good thing to do.
So for each iteration of the loop, we'll run the get next sample before we do any kind of drawing plot or
now it should be
plotting.
Crammed against the top. All the way across. Yeah.
So now we have this kind of saw edge looking thing at the very top, and that's because
can I guess?
Sure.
That's because, let's see, we start out at the top at 0, and then as we go down in y, that number increases, of course, our height, if you will. And what's happening is our sine wave is giving us a positive 1 to a negative 1. So our negative 1 is getting chopped off. So we're going 0 to 1, 0 to 1, 0, and 1, well, that's 1 pixel, so it's teeny. So
that's why we have such a small wave. And then the negative stuff, all of these values on the window, coordinate-wise, are positive. So every time we drop negative, we're actually dipping off the window.
Yeah, exactly. So if you go ahead and adjust your Y now, you can put it down in the center, and they can see the top and the bottom, and we'll be dealing with a 3-pixel high wave all the way across.
And this gets back into why I was using X and Y variables. So we take our data and we adjust it so that it looks better and is centered on the screen.
Right.
So if we take your sample value and we add half of the client height, then we should have the center just like with the flat line. And client height divided by 2. Of course, I can use the division instead of the integer division here because all of this is a float,
right,
and we're then rounding it off. So that's why I can get away with
so prepare for a teeny little bitty wave. Woo!
So it still looks like a little kind of saw edge because we're only adjusting by maybe a total of 3 pixels.
Okay.
But we do in fact have something that's now centered within the window.
So now we can start doing something to make it bigger.
To do that now, it would be nice to have our getNext sample set up to take in some way to modify the sine wave, give some attributes to the sine wave.
Like we can control amplitude and perhaps how close each of the waves are, the frequency.
So to do that, we could go in and adjust our getNext sample procedure. We'll change it so that we take in arguments. And those arguments are amplitude and frequency. Both of those will be taken in as floating point singles. And I'm going to copy all this information just so we have an exact copy of this procedure down here with getNext sample.
Okay.
And
yeah, of course we need to send that information to it.
I was just building it there to make sure I had typed it in.
No, I was just saying that's what the error is going to be.
But yes, when I try to build it, it's now complaining because we're using getNext sample, but we're not specifying those arguments. So we could feed it a 1 and 1, and we'd have the same effect, but we've already seen that. So let's set our amplitude to 10 now.
Okay.
And see what the result of 10 would be.
But now we got to actually use it inside the procedure.
Jumping one step ahead.
So we just multiply the outcome of the sine of the sample number by amplitude.
Because the sine is going to return negative 1 to 1. And if we multiply that by amplitude, we could get a larger or smaller wave.
Which in this case would give us 10 to negative 10. So now we're getting something that looks a little bit nicer. Ah, there we go.
So we can definitely tell that we're now extending up and down a lot farther with our wave. So now we got
20 pixels we're dealing with.
So we still have a wave that's packed together very tightly, so we need to start using frequency. Now, to show a frequency adjustment within the sine wave, we need to adjust how quickly our sample num changes, at least as far as the sine itself is concerned.
Right.
If we make it so that the sample num changes more quickly, we'll have a tighter waveform. Mm-hmm. If it changes more slowly, we'll have a more gradual waveform.
So we can multiply frequency in there.
So I'll drop this in place. And yeah, if I'm in the middle of typing something and I mess it up, then that's it. So if we multiply by frequency, we could make it operate faster by having a value of greater than 1, or have the sine wave more gradual by having it less than 1. So let's try that out and set our frequency to 0.1 and see what the result of this is.
Ooh.
There, we have a much more gradual slope on the entire waveform.
Nice.
So that's the heart of the application in place. We have drawing code and we have sine wave sampling code. Now we'll spend a little bit of time and make this app easier to work with, because right now you have to hard code some numbers, run the app, and then hit the generate button. It would be a lot better if we could set those values when the app is actually running. So if we drop some kind of slider, we could change the value in real time and see the update. So I'm going to jump down over to the Win32 section, grab a track bar, and we'll use track bars to represent or to input the parameters for our waveform. So we'll begin with this one. We'll have an amplitude track bar and we'll have a frequency track bar. So this is the first one, so it'll be amplitude. So jumping down here to name, we'll call this TB amplitude. And set some other things to make this look a little bit nicer. We can take our thumb length down to 15, and let's change the range so that it goes up to 100 or, well, let's see, this is a form, so that's probably at least 300 pixels that it could show. So we can go 0 to 300, and since 0 is going to give us a flat line, if we have no amplitude, it'll just be a flat line across the screen. So I'll set the starting position to 30 instead of 0. So we have something we can see to begin with.
Right.
And it would also be nice to be able to see the actual numeric value that we're using to influence the sine wave. So I'll drop a label into place. And this label, I'm not going to set the text yet. I'm going to have the text be set internally when the code's running. So the caption is irrelevant for the time being, and I'll set the name to LBL amplitude. Maybe slide it over to the left a little bit, slide this over to the right. And that's good for our first slider and label, so I'll copy those and paste them, move them down a little bit, and then this can be our frequency track bar and label. So for frequency, let's jump down to name, and same thing. Except not that property.
Da-da-da. There we go.
Still horizontal.
Up one.
We've got track bar. This will be TB frequency for the frequency slider. And the label will be LBL frequency.
Back up, grab the label.
Whoops, grab the form. And caption, no, we want name. Name is LBL frequency.
Perfect. All right.
And that's good. I am going to change the max. We'll change this down to 100 for now. We will probably end up messing with this a little bit to fine-tune it in the end, as you'll see what this is going to result with visually. So we've got some sliders, and now we need to take these values and use them back in code. So if we jump back over to our for statement, here we have our hard-coded values. We can now replace them with track bar values. So TB amplitude dot position and frequency dot position.
You might want to start out by setting that frequency max range to something more like 1 or 2 instead of 100.
Right, because even 1 is actually pretty.
It's going to be
pretty
very
dense.
Yeah. So set it to 1 maybe. Up, put that back to
position 1.
I'm thinking max. I wouldn't take the max. You said the max to like 5 or some small, because 100 is going to be insane.
Yeah, it'll basically just keep wrapping over itself.
I know where you're going with it. We'll adjust that a little bit later.
Right. Okay, so we've got frequencies, position, amplitude. So we've got our sliders now influence the wave, and we should be able to test this. So if we run, we can generate the wave, and then we have an amplitude of something we're not reflecting yet and something else we're not reflecting yet. So we can move this somewhere else, regenerate, and notice the problem we get.
Yeah, we get a very interesting problem, and it's going to start out with, two things. One, we're not clearing our form before we draw again. And second, look at increment sample down there in the, put your mouse over, thank you, in the get next sample. Where do we ever reset that? It just keeps getting bigger and bigger. So that's two things to think about.
So the first one is that sample number. Since in order to regenerate the wave, we want to begin at the beginning, so we need sample num to be reset to 0 before we go and rerun the calculation.
Actually, at the risk of making myself sound like an idiot. No, that's correct. I was going to add something else in there. But now we got, go and change the amplitude, and you can see that it's never being cleared before we draw again. So what we need to do now is go ahead and clear the form and then allow it to draw again. Right.
And since clearing the form involves a few different things we have to do, I'm going to put that in a separate procedure. So we could start a procedure called clear form. And the clear form, its job is to take and redraw the entire form to gray. So we need to have our canvas set its brush color to gray. So CL, BTN, face, so our current Windows button gray color. And then we'll have the canvas fill the entire form, or fill the entire client area with that gray color. So we'll use fill rect, and we'll provide it with the client rect. And that should redraw everything to gray. Now, back in our generate sine wave, we can begin the entire thing by having it clear the form. And I have, let's see, what do we have? CLBTN face. I was saying the brush. The brush has the color. It's not the color. Now we can compile, and when we generate, we have our wave, but now we've erased our labels. This appears to be just because of the way labels work and their dependence on the form's canvas. So we can fix this quickly by having our labels redraw right after we refill the canvas. So we could say our label amplitude, and we can have the labels repaint themselves. So LBL amplitude repaint and LBL frequency dot repaint. And this, if we build and run, whoops. Now we keep our labels and we draw the waveform. So if we draw a larger waveform and a smaller waveform,
nice.
We have only one waveform drawn at any given time.
Very nice.
So since we're messing around with visual stuff, let's go ahead and plug in these labels so that they update based on the sliders. So we'll do that every time that they're drawn, since we're being fed our amplitude and our frequency at this point. The final amplitude and frequency that actually get used, we'll draw those at the beginning of the getNextSample procedure. So we have our label amplitude. We'll set its caption to the formatted, or we'll use format to drop amplitude into a string we can use in caption. So format, and we'll say that the amplitude is equal to %f, and then we'll provide it with the amplitude variable. And then the same for frequency. So LBL frequency, and it says frequency is equal to the given frequency. So now when these are changed, we have...
We
haven't regenerated yet. So we regenerate amplitude 20, gives us this amplitude.
Yeah, so now it's time to get rid of that button so those things, we start getting some automatic work in place.
Right, since we have an on change, if we go over to the actual track bar itself, under its events, we can set up an on change so that we redraw by dragging instead of redraw by hitting the button. So we could say, and of course we have that generate sine wave.
Yeah, it's just generate sine wave. How convenient. You guys hopefully by now are really starting to see how functions and procedures can be so helpful.
I'm going to do the same for both the amplitude and the frequency, so either one will regenerate the sine wave.
And on forms creation as well, because if you run it,
we don't get anything yet, but then
the moment you start doing that, then we do.
As a matter of fact, along with the create, we could also add a generate sine wave on resize, because that way when we move or size up the window or maximize the window, it'd be nice to have that reflected as well.
Agreed.
So, now, let's see.
Also, you got one open. There you go.
So immediately...
how nice is that? It's already there.
So we immediately have our labels come to life. We have a waveform. We can mess with the waveform by simply dragging the sliders. And if we resize the window, then it stays in view.
Okay, very cool. Now we got to do something. Well, we can go ahead and get rid of the button, and then we can start taking a look at that frequency. Let's clean that up a little bit.
All right, along with the button, I'm going to go and take out the procedure as well. Just have to delete the line, rebuild, and it'll clean up that procedure for us.
Cool. So now go ahead and run it again. Let's take a look at the procedure. The frequency. Show them what it's doing that's not quite very convenient.
All right, well, starting off at 1, we have a very dense waveform. And as we go from that, we get more and more and more dense. And it would be nice, remember when we had done one of the first drawing examples with frequency where we had 0.1? That gave us a nice gradual waveform.
Right.
It'd be nice to get those values back. So what we need to do is we need to take this integer-based track bar and adjust it so that we have a range over a floating point range. In our case, a range of maybe 0 to 0.1 or 0 to 1 would be nice, because then we could get into some of those smaller decimal values. Of course, we can't directly do that, because position is an integer. If I jump over to code for a second and I go look down here at position, that's an integer. What we can do, though, is take our given integer range, because we have a range of 0 to 100, so we have 100 different units, or a resolution, if you want to call it that, of 100. And we could divide that by 100, and now our max value is simply going to be 1. But we still have a resolution of 100 across that.
Big difference.
So we begin at 0.01 instead of 5. And then, now I can jump this back up.
Exactly.
But, because we had set this to 5 just so we couldn't do anything crazy with it to begin with.
Right. Now you can give it the higher number.
So we can give it 100. If we gave it 100, then we could go all the way up to 1.
Yep.
And even with that much or even with that much resolution, we still have a lot of jumpiness to begin with. So I'm actually going to up it all the way to 200. And then have our code divided by 200. So we still have the max of 1 that we see.
So we just got double the resolution from what you just had.
Exactly. So now we have a much smoother progression here. Though something interesting does happen. If I move the trackbar with my arrow keys, you can see we have some movements without the label updating. Or rather, it is updating, but we need more accuracy than 2 decimal places. So we can jump down to the procedure and tell it that we want 3 decimal places shown. And now we have 0.05, 0.10, 0.015, 0.020.
Very nice.
So we have an accurate numerical display, an accurate slider, and nice response on the waveform.
Very nice. Now, what kind of loop are you using?
Well, right now I'm using a for loop.
Well, we've looked at using a repeat loop. We looked at using a for loop. And in this particular case, with the for loop, remember, it's going to go a predetermined number of iterations. And that's what we've got, 0 to the width of the client. Let's take a look at how we can change that up so that it is a while loop.
Okay. And let's see. Instead of erasing this, I might just comment it out so we can compare it when we're done changing it.
Sure.
Let's replace this for loop with a while loop. So we could use a while. Now we need some expression to say, or to let us know when we're at the end. Now we've got this sample num that we're keeping track of for waveform sampling purposes. Now we could use that in our while loop. So we could check by saying while the sample num is less than the given width of the window. So as long as we haven't used up our window for sampling purposes, and we have our begin and end set up. And really, it's as simple as that.
It's that simple, except in this particular case, it allowed us to get rid of the variable I.
So back over in our variable section, we can simply erase that, and now we have one less variable to worry about. So it builds just fine, no errors. We run, and the behavior is exactly the same as it was before.
Very nice.
So that cleans up our code as far as readability goes, because now we have some relevant value compared to the width of the screen.
And in this particular case, it's more efficient.
Right.
All right, guys. Well, that is pretty much going to bring episode 9 to a close. I'd like to thank you for joining us. And again, while there are a billion different examples we can give you guys of loops, we wanted to keep it as simple as possible and the lecture over the hardcore loop part itself, keep that really, really simple. And I think you'll start really getting a good feel for how loops work as we start progressing into more practical examples, with this being our first couple, basic practical examples. So that's pretty much for loops. Just remember, we've got 3 different kinds that we're going to be working with: the repeat loop, the while do loop, and the for loop. And with that, the next episode, we've got something really cool planned for you. It will be, I think it's going to be our final break away from the MP3 player before we get back into it, but we're going to be developing something that I think you guys are really going to dig. Very cool stuff. So this is going to wrap up this episode. Again, thank you guys very much for tuning in, and I hope you got a lot out of it. And we'll see you real soon in episode 10. Take care.